Right, this is the 5 volt supply out of the MDS. The supply itself is okay, it certainly tests alright anyway, but I thought I'd give it a bit of a going over and then try and figure out how some of it works. If we have a look around here, we've again got quite a large transformer here. These devices here that look like transistors aren't actually transistors. You've got a very good view of that. Let me just move you over a little bit. You've got a little bit better view. They're actually 2 power diodes in a TO3 case, which confused me a fair bit to start with. Underneath these heat sinks, there's 6 power transistors in parallel. They control the 5 volt supply. The other end, there's a SCR crowbar again, as we saw in the 12 volt supply, and this power transistor here controls the power to the regulator board. Alright, what I'll do, I'll turn it over so we can see the other side. Right, well, this is the other side. It's basically broken into 3 sections. So we've got transformer, we've got the sort of power control board in the middle, and then we've got the driver board on the left. I've taken out the reservoir capacitors. They're here because I wanted to clean everything up. It was full of the crusty flux again, like the other board was, and also there was a little donut joint on this transistor which I've fixed. Basically the circuit looks to be something like this. Another one of my shocking drawings, but this section of the circuit is repeated 3 times. So we've got centre tap transformer, the 2 diodes as we saw before in the other circuit, reservoir capacitors, 2 transistors in parallel, and the 5 volts coming out of the emitter. There's a couple of individual windings here which are the power supply for the driver board. Right, so looking at the transformer, these thick grey wires here are the 3 centre tap windings. These are the outsides, and on the opposite side is the centre tap. And you can see that those grey wires, if you follow them down, go onto the power rectifiers, which are built into these TO3 cases, and that's just repeated 3 times. It's all the same. The other thin white wire and the thin grey wires, they're going off to the driver board over here, and they form part of the power supply. I've not drawn that. I'm not quite sure how that works, but anyway. So the next bits we can tell from this side, we can see the 6 power transistors, which are here, here and here. They are all in parallel, or at least the collectors and the emitters are. The base is driven via a resistor, which I think I've drawn the circuit here. There we go. Right, so that's the one there. And that's how that bit works. And you can see these 3 wires that come in here are the drives to the 3 pairs of parallel transistors, which again are paralleled up again, and they come off the driver board, as you can see down here. Ultimately the power supply comes out down here. We've got, what have we got? We've got 2 sort of fat red ones, a thin red one, 2 fat black ones and a thin black one. I think the way it works is these outer ones are the power, and then the thin ones are sense wires. So when we saw on the main board, there were actually small terminals and big terminals, and these thin wires go to the small terminals, and it's probably just to allow for any volt drop across this cable. Right, so that's the sort of basic overview of it. The thing is, you obviously have to be fairly careful with this, because everything's in parallel and you could actually miss something. Right, okay. So it'd be worth checking these diodes, which I actually have done. I can probably, let's just if we can get the meter in shot. stick it on diode check. It's over there. There we go. It's almost in shot anyway. Right, so what we'll do, I'll clip this on there, which is the output of that pair of diodes. If I clip the red lead on there and the grey lead on there, we get absolutely nothing, and we should find the same thing on the other side. So obviously the diodes are reverse biased at that point, so if I swap them over, we should see the diodes conducting. Oop, there we go. A bit short there, and the same thing should happen on the other side, which it does. And obviously you'd have to repeat that for the other three. I won't do that now because I've already done it. I can also show you that the collectors are all connected together. So you've got a short circuit there, and also the emitters, which I think are on this side. Hang on, maybe it's the other side. Ah, there you go. Sorry, got me base and emitters mixed up. Right, so the emitters are shorted together as well, and that's the same for all of them as well. If we went across these two, we'd find the same thing. There you go. And those two. There you go. And the base is driven off these wires here. So if we just check that. There we go, and there's a bit of resistance in there, and I think that will turn up on all of them, but they're not shorted. There is a resistor on each one. Try down that one then as well. There you go. You sort of think that because they're all in parallel there might be a bit of a problem, because obviously the transistors might be different gains. It's not a problem because as the voltage builds up over the load across here, it effectively creates negative feedback. So if any of the transistors starts conducting, the voltage will start to rise here, and that will effectively cut the voltage down on the base. So, well, that's in theory how it works anyway. It obviously hasn't blown up until now, since 1974, so I'm sure we'll be fine. Right, I think that's about it. Can't tell you much more because I haven't got a proper drawing of it, but other than that, we can see the 723 regulator here, which we've seen before, along with the circuits. There's a pot here which sets the 5 volt, and there's a little one at the top here that sets the current limit. I haven't touched that. I think that's about it. So what I'll do, I'll put it all back together again with the reservoir capacitors in, and then we'll do a load test on it and see how we go from there. Right, we'll get it all set up. Just a correction from the previous segment. I should have said 1977, not 1974. As a number of you might have noticed, it's got 77 printed on the case, isn't it? But there you go. And it might have been a bit clearer if I'd said the base emitter voltage was reduced as well when I was talking about negative feedback. So anyway, a couple of corrections. It's powered up, has been powered up for getting on about 4 hours now, I think. It's getting quite warm. What I've done, I'll just pan the camera around a bit. There we go. I've bolted the power and the sense cables together. As you can see, you can probably just about see there and there. I've got a couple of lamps here. They're not that bright because they're 12 volt lamps, but overall it's drawing about sort of 4.5 to 5 amps, so it's giving it a bit of a workout. Nowhere near the 40 amps it's rated for, but haven't got enough bulbs to do that. Got 5 volt in the meter. I can, if I switch it around to AC, oh, there we go. That'll give us a rough idea of noise. Looks pretty clean. So that looks like it for that one. One thing might be interesting, this I showed you this in the first video. This is the thermal trip. I thought it was finished, to be honest, because you can see how much corrosion there is here. But I've cleaned up the other side, and it doesn't look too bad actually, so we might even better reuse that. Right, that's that then. Let me just switch that off and put it out of the way. Yeah. Right, the plus or minus 12 10-volt power supply is back together again. Just finished testing this. This was on for about 3 hours. Didn't have any problems. There we go. I did change all of the 723s in the end. So I put all 3 of those are in new. Capacitor got a bit singed, I replaced that as well. And also the transistors on the back, they're all new as well. So that's had a good overhaul. So these are both ready to go back in the case. So that'll do it for this one, and I'll see you next time.